After we discuss about the big O analysis, it is time for us to look at our very first data structure, which is going to be about the lists. This can be considered as our daily life list. But before we move into the list, we need to talk about what is the ADT, abstract data types. This is basically in the title of our textbook, and we need to understand what is the concept and what is the meaning of abstract. So to solve a problem, it involves about the data. How do we deal with the data? And basically this is the main thing about the data structure class. So in order to do that, we need to identify the following two things. First of all, the collection of the data items. What kind of data are you trying to collect? And based on your problem, the second thing is about the basic operations that can be or must be performed on those data. So how do we deal with those data? These are the two major things that we need to work with in order to perform a good data structure. So abstract data type, or ADTs, is a type for objects whose behavior is defined by a set of value which is corresponding to the collection of the data items and a set of operations. The word abstract means that we only want to define those two things. What are the data and what are the necessary operations that's needed, without discuss of how do we implement those. Because the implementation is going to be independent from the problems. An interesting thing about computer science is that for one problem, there's probably millions of different ways of solving the problem. And therefore, in the idea of the abstract data type, we simply define the problems and then we try to use different ways to implement the approach. So that we think in abstract data type concept, we think what can be done with the data. And we don't worry about how do we deal with it until we go into the implementation process. So we separate the design phase as well as the implementation phase. And that the process of providing only the essentials and hiding the detail is what we call the abstraction. So in our data structure list that we want to discuss today, we will implement this concept. So let's try to understand what is the list. List can be considered as our daily life things, grocery to be purchased list. During the time that you go into supermarket, sometimes you have a long list of items that you want to purchase. Maybe they are sorted by the priorities, and maybe they don't. It doesn't matter. But all the things listed on the list are the groceries or the things that you want to purchase in the supermarket. So they have some connections. The data or the lists that you list over the list are related to each other. They have a main thing. Job to-do list, list of assignments for the course, things list. Try to understand, try to think about what kind of items list on each list. Such as things list. They are student names. So you list all of the different student names on the list. It is going to be very weird that during the list of the things list, you have milk that you want to purchase in grocery, right? So they are under the same thing. And there's many different things about lists that can be come up with. So list, if we try to talk in computer science perspective, list is a collection of things. One important thing over here, it's homogeneous. What does that mean? That means the elements are all of the same data type, if that's what we're going to look at. If that's the numbers that we want to store, then they are all numbers. If they are characters, they are all characters. Or more important, if they are names, they are all names. So they have what we call a homogeneous data type. More importantly, it has finite length. So the list has certain amount of numbers listed over there. It is not going to be infinite. The elements are arranged sequentially. So you have one item followed by another item followed by another item. I know what you are thinking right now. Basically, you are thinking about array. And that's totally fine. That's totally correct. Because array is one of the implementations that we want to deal with. But like I mentioned in our earlier time, abstract data type is not going to talk about the details about the implementation because there are going to be several different ways of implementing this. In this topic, I want to talk about how do we implement the whole thing in array, how do we implement the whole thing in linked list, and how do we implement things in vectors. So there are three different major things that we can implement the problems that we define over here. However, before we do that, we talk about the conceptual design, which indicating what are the needed functions for this problem. So let's continue. The list IETs. Collection of the data elements, basically we talk about data and we talk about the basic functions. When we talk about the data, a sequential with finite number of data items, all of the same type. So that is the requirement for the data. And then in order to implement the list, there are 5 basic important operations. First of all, construction, indicating you want to create a space. Whatever type of things that you want to implement, it doesn't matter. At this stage, you are creating an empty list so that for the following functions, they can continue based on the structure you provided. The second function is going to be empty. This is a Boolean function, returns 0 or 1, indicating if the list is empty. So if the list is empty, you return the value of 1. If the list is not empty, you return the value of 0. So again, this is a Boolean function. After that, we want to look into 2 most important functions in the list. One is insert, so that you want to create a new item, put into your list. The other one is delete. You want to say you get your grocery and you want to remove that item, so that is about a delete. Among all of the operations, traverse is indicating that you want to list everything in the list. So that is basically a loop that will go through all the items that you have in your current list. So you can see that when we're talking about this size, this is exactly what we want to talk about, the abstractions. We're indicating what are the necessary functions, what are the data that we are looking at, and we don't talk about how do we implement it. We just say that as long as whatever implementations that you choose can satisfy these requirements, then that is the implementations can be applied to the list. And therefore, this is the idea about the abstract data type. So this is the design phase of the implementation. So in order to build a list class, it consists of the 2 steps. One is about the design, and that is the previous slide is the design phase. And then we will move into the implementation phase of the class. Design is to implement ADT consists of identifying the functions of the members that are needed to be carried out. It is important that we describe the function member independently of how the class will be implemented, because that is simply a design phase. Function members must be described in some manner that is not depending on any particular representation of the objects. So, design the list class should contain at least the following function members. Constructor, which is creating the space. Empty function, a Boolean function. Insert, delete, and traverse, which can be also described as a display. Show all the items over there. So these are the design phase of the list. And therefore, after the design phase is done, we will be able to move into the real implementation. Like I mentioned, there are 2 major implementations plus a vector implementation. We will start talking about the array-based implementation, understanding that the list is probably most naturally implemented by the array because the similar concepts represented in the array. However, there are some problems we want to talk about, and therefore we will need to look into the disadvantages and then try to see what other options that we have, which goes to the linked list implementation as well as the vector implementation. So let's start with the array implementation. After the design phase is done, we are now looking at the implementation phase. So in this phase, we would look into a particular method of implementing the requirements that we have specified. So array is the most common structure for storing list items. Why is that? Because first of all, elements are sequential. You have index. You have all the spaces that you want to store. Most languages support array. All the languages I know, they all support array. Algorithm development is pretty straightforward. So array that seems to be a natural storage structure for implementing a list. Normally, sequential orders of the list element are matched with array elements. So we have all the indexes and we have the values being stored in the array. More importantly, when you define an array, you provide a data type. So everything in the same array have the same data type. Of course, the array must be large enough to hold all the elements that you have. And therefore, in the beginning of decorating a array, you need to specify enough space for that. So in the array implementation, there are several important variables that you need to understand and need to remember what they are for. First of all, of course, is the array itself. The array that stores the list. You need to provide a name for the array. You need to provide a data type. And more importantly, you also need to specify the capacity, indicating how many spaces that you have in the array. So when you try to define an array, you need to define the first two things already. That is part of the constructors that we are talking about. You need to create a space, provide the basic information that's necessary for the implementation. And then you need to indicating the size. Size indicating the number of these elements that are stored in the array. And therefore, in the beginning or the constructor phase of the array implementation, you declare the data type, the array name, and the space indicating the capacity. And then you need to set size equal to 0 because there is nothing during the constructor phase. So you have prepared everything, including all three variables, and therefore you will be able to have a space that to carry out your array implementation for the list. The Boolean function, empty function, is very easy because you have the size. As long as the size equal to 0, that is empty. If the size is not equal to 0, it is not empty. And so these two functions are very straightforward for the list implementation. Traverse would be straightforward because you already have the array. You know the size of the array, that indicating how many elements that you have. So as long as you write a loop, go from the beginning, which is at index of 0, goes to size -1 because it starts with index 0. So you need to remember to -1. That will give you the last position of the array. And then every time you go through one item, you print it out everything, then you would be able to traverse every single items inside of the array. So that is the 3 out of 5 functions it discussed in the list. Next, we will discuss about the insert as well as the delete functions or the implementations in the array.